So let's begin with the universe. I think that would be an appropriate place to start. The universe can be defined as all of space, all of time, and all of the contents of space and time considered all together. How old is the universe? People have always known that the universe must be very, very old because humans are very, very old. We can trace our ancestries very, very far back. Currently, scientists believe that the universe is around 13.8 billion years old. And the story currently is that it started, at least materially and physically, after an event known as the Big Bang. The observable universe, the parts of the universe that we can actually see, is around 93 billion light years wide. And the universe is expanding. It seems to be expanding. And in fact, that rate of expansion is accelerating, supposedly due to dark energy. There were pre-scientific models of the universe. If you were to consider modern science as being around 500 years old, although really it's so arbitrary, the cutoff point. Anyway, as I was saying, there are pre-scientific models of the universe that were Earth-centric, placing Earth at the very center of the universe. Modern models of the universe, say that there is in fact no center, and no edge either, and that it's largely uniform. Whichever direction you look in, it's more or less the same at a sufficient scale. The prevailing current model is the lambda CDM model. It's called the lambda cold dark matter model, and it asserts that 70% of energy density is dark energy, 25% is dark matter, and the remaining 5% is the ordinary matter that you and I interact with on a daily basis. So gravity coalesced early hydrogen and helium gases to form the first stars. Our sun is a star, and it's one of about 200 billion stars in a structure called the Milky Way galaxy, which is itself one of around 200 billion galaxies in the observable universe. It's believed, but no one knows for sure, that the observable universe will continue expanding and may culminate and end in something called the heat death, which is where basically everything just freezes because everything is too far away from everything else. Now let's talk about stars. What is a star? A star is a massive plasma sphere, mainly made of hydrogen and helium. Our star, the Sun, is roughly 3/4 hydrogen and 1/4 helium. They begin as a sort of a cloud of dust called a nebula, and then they collapse in on themselves by gravity. How many stars can we see in the night sky? The number varies quite a bit depending on where you are, depending on the conditions of the atmosphere. Some people can't see any stars at all. But under the best conditions, there's around 4,000 stars that you can actually see. And we group them into constellations and asterisms. Constellations and asterisms. Constellations are patches in the sky. That's why you don't get new constellations each year. The number of constellations is fixed because the sky has been divided into a fixed number of patches. When you have 4 or 5 stars and they're lined up and they kind of form like a shape or something like that, like a trapezium or something, that's called an asterism. An asterism. And how many stars are there in total? Like, if I had my telescope and I could count every single little star, and it was the most powerful telescope ever, and it could somehow see every single star. Well, nobody really knows, because stars are being born and dying all the time. But there may be roughly 10 to the power of 24 stars, which is about a trillion trillion, which is about a trillion trillion stars. And that's more than all the sand grains on Earth. If you were to count up all the sand grains on Earth, there are more stars than that. Okay, so how do we classify stars? How do we put them into groups? That's a very natural question, right? Like, which star is which? We classify them by temperature and brightness. Most stars are red dwarfs. Most stars are red dwarfs. What about our star, the sun? The sun is a yellow dwarf. What's the closest star to Earth, other than the sun? What's the second closest star to Earth? The answer is Proxima Centauri, the system Proxima Centauri, because most stars are not singletons, but binary stars, like 2 stars together in a system. Our star is a singleton. It's by itself, and that's kind of rare. Like, it's uncommon, I should say that. So, okay, so how close is this star system? It's 4.4 light years. So, if a beam of light was traveling from your torch to the closest star, second closest star, it would take 4 years and 3 months to reach there, if it could reach there. And what is it that causes stars to actually shine? Why does the sun shine? It's because stars are powered by fusion, by the fusion process. Hydrogen fuses into helium in the star's core. It's a lot more complicated than what I'm saying, but roughly speaking, that's basically what happens. It's definitely not fire, okay? And okay, now, what about the life cycles of stars? What about the life cycles of stars? Well, for stars that are similar to the sun, our sun, they're at first they're protostars, and then our star right now, the sun, is in a main sequence phase, and then it's going to swell up and become a red giant, and then it will shed its outer layers and become a white dwarf. Okay, and what about stars that are much bigger, much more massive than the sun? Well, they will, at the end of their life cycle, they will undergo a cataclysmic event called a supernova. A supernova, which is pretty much like the most energetic event that I can think of. Yeah, and what's left behind after a supernova could be either a neutron star, or if it's really, really massive, it's a really massive star, it could then form a black hole. And what is it that actually forms elements in the first place? Why is the whole universe not just full of hydrogen? The answer is it's because of a process called stellar nucleosynthesis. This is what forms elements past lithium. So you have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, etc., etc. But to form elements past lithium, you need stellar nucleosynthesis. Now, okay, so our star, the Sun, has planets orbiting it. There are planets outside of our solar system as well. They're called exoplanets. Okay, so let's talk about the Sun, because I've mentioned the Sun a few times, but I haven't said anything really about it. That apart from it being a yellow dwarf star. Now, is the Sun the center of the solar system? Kind of. Basically, it is. But did you know that when the Earth orbits the Earth actually pulls on the Sun a little bit? So it wobbles the Sun a little bit. And so do all the other planets. Just a very tiny amount. So is it the center? You tell me. But, okay, so when did the Sun form? About 4.6 billion years ago, from a collapsing molecular cloud. And how big is the Sun? It's 109 times as wide as the Earth, which is very close to the number 108, which is a very magical and enchanted number. If you ever look into 108, it's a very interesting number and I love it. But anyway, how many Earths could actually fit inside the Sun? The answer is 1.3 million. That's how many Earths could actually fit inside the Sun. And how far away is the Sun? Okay, instead of me saying this number, how about you imagine that there is a magical road that goes from the Earth to the Sun. And you have a car with an infinite amount of fuel. And you're traveling at highway speed. How long would it take your car to reach the Sun? Roughly 200 years. That's how far away the Sun is. The real number though, is 150 million kilometers, which is about 400 times further away than the Moon. And the Moon itself is about 400 times smaller than the Sun. I think it's really, really, really weird that the Moon lines up so well over the Sun. Right? It doesn't line up perfectly, because when the Moon is in front of the Sun, you there's an effect called Bailey's beads, which you can see on the outside. But anyway, I just think it's really weird how close it is. Like, it didn't have to be that way, but it is. And let's see. Okay, so how much mass is actually in the sun? Well, certainly more than 99%. It's closer to 99.9% actually. The sun has pretty much all the mass in the solar system, nearly all of it. And by the way, earlier on, when I mentioned how far away the sun was, which was what? 150 million kilometers. We have a special name for that unit, that amount of distance. We call it 1 AU. That's 1 astronomical unit. And let's okay, so did I say what the sun was actually made of? Oh, I think I did. 3/4 hydrogen, 1/4 helium, right? Yeah. Okay, so the real number is about 73% hydrogen and 25% helium. But it does have traces of heavier elements. Now, how much fusion actually takes place in our sun? The answer is about, imagine a mountain on Earth. Every single minute, an entire mountain of fuel is used up in the sun. So about 600 million tons per second. 600 million tons of hydrogen is turned into helium every single second. And how hot actually is the sun? Well, that's a complicated question, because what do you mean by, what does it really mean when you say about the temperature of the sun? It's very complicated to actually answer that, because because the sun doesn't have a surface, and it's not like here's non-sun and then here's the sun. It's got a very large atmosphere, and roughly speaking, though, about 6,000 degrees Celsius on the part that you would definitely call the sun, the outermost part of the sun. It's about 6,000 degrees Celsius. And in the core of the sun, it can reach 15 million degrees Celsius. Extremely hot temperature, right? And why am I grateful for the sun? Why do I care about it? Well, of course, it supports all life on Earth and the climate of the Earth. But, and in fact, this is why in old religions it was considered to be a god, a sun god, a solar deity. And, you know, if you could only think about physical things and you couldn't have ideas, abstractions in your head, probably it's quite reasonable to think that the sun is like a type of a god or something. It makes a lot more sense than, you know, just saying a microphone is God, right? I'm just saying that it makes a lot more sense. But anyway, it's the basis of all our calendars. That's true. No, it isn't. No, there's the solar calendars and lunar calendars. And then some people combine them together to have solar lunar calendars. But what was I going to say? There are these things called coronal mass ejections. And these actually threaten all life on Earth. Basically, the sun, although the sun seems extremely stable, don't forget that it is basically just a constant explosion, like in space, a nuclear explosion all the time in space. And yeah, sort of a coronal mass ejection, like this happened with the Carrington event in 1859, where fortunately, I mean, if that happened today, the internet would just completely cut out and be destroyed. It might not be destroyed actually, but the sun is about middle-aged. It's about halfway through its life, and after another 5 billion years, because it's about 5 billion years old, it will turn into a red giant, and it might engulf the Earth. It might not. We might miss it, but I don't think human beings will be here to worry about that. By the way, this is interesting. If you if you take mass away from the sun, it will actually live longer. It will live longer. And so in science fiction, there's something called stellar lifting, where you sort of fire a laser at the sun and you can sort of extract mass out of it. And so the sun's life is extended. And some stars can live for trillions of years. So, yeah, that's how you could solve that temporarily. But it will turn into a white dwarf, which will then cool to death, turning into a hypothetical black dwarf. But we've never observed those. Okay, so what is a planet? What is a planet? We are on a planet right now. But what is it? Well, it's a large, rounded, astronomical body. Oh, but wait a minute. Why are there just 8 of them? Aren't the asteroids planets, or what? That's not enough to define a planet. You have to also say that it's cleared its orbit of debris. So anyway, okay, so what planets are there in the solar system? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay. All of them, except for Mercury, have atmospheres. Although, to be fair to Mercury, it does kind of have a few sodium vapors. I don't know if you would call that an atmosphere, but it kind of does have one. And all of them, except for Mercury and Venus, have moons or natural satellites. The giant planets, Jupiter, Saturn, Uranus, and Neptune are gas giants, and they can have rings. Saturn obviously has rings; it's very famous for that. But Jupiter also has rings, and they, historically, they were differentiated from stars by their wandering paths in the sky, and this is where we get the word planet from. It means wanderer. So, all right. So, which planets could we actually observe with the naked eye? Well, interestingly, last month, on the 21st of November, you could actually see Uranus in the sky, very briefly. But for practical purposes, the amount of planets that we can see, it just goes up to Jupiter and Saturn. Mercury, Venus, Earth, Mars, Jupiter, and Saturn. It's telescopes which added Uranus, Neptune, Ceres, which is an asteroid, and Pluto, which is a dwarf planet. The International Astronomical Union, IAU, defines a planet to be something which orbits the sun, which is round, and which has cleared its orbit. So now Pluto is defined as a dwarf planet in the Kuiper Belt. And as I said earlier, there are exoplanets like hot Jupiters and super Earths, which are big, giant versions of Earth, kind of. Okay, so after talking about planets, I would like to talk about the moon. What is the moon? The moon is our sole natural satellite. Okay. When was it formed? Well, some people think that it was formed when the Earth was formed, but no one really knows. But one working answer that some people believe is that it was formed around 4.51 billion years ago because of an impact. Something crashed into the Earth called Theia, and that's how we have the moon now. It's after that impact. The debris coalesced, and that's what formed our moon. That's a belief that people have. I don't believe it, but anyway. Okay, so how wide is the moon? The answer is 3,475 kilometers, which is about 1/6 as wide as. No, rather, it's about 1/4 as wide as the Earth. Where did I get 1/6 from? Why was I thinking 1/6? Because that's the strength of the gravitational field on the moon. If I were to teleport you to the moon, you would weigh 1/6 what you weigh on Earth. Now, the moon orbits the Earth on average every 29.5 days. Every 29.5 days. And as we can see in the sky, it undergoes lunar phases. Like you have the new moon, which is where it appears black in the sky. You can't see it. Then the moon becomes more white. It's waxing. And then you get a half moon. And then you get a full moon. The intermediary stages are called the crescent phase and then the gibbous phase. Yeah. How far away is the moon? The answer is 384,400 kilometers. 384,400 kilometers. So if you were walking your entire... let's think about how far away that actually is. Okay? So the distance around the outside of the Earth is 40,000 kilometers. Okay. And if you were walking at an average walking speed, non-stop, constantly, it would take you approximately 1 year to walk around the circumference of the Earth, if you could do that. And the moon is approximately 10 times further away than that. So you would walk to the moon in 10 years. But wait a minute. People, if they're healthy, they do spend around 10% of their day walking. You should spend around 10% of your day walking, usually. And therefore, over the course of a lifetime, you will walk from the Earth to the moon. You see? Which is kind of interesting. And every 10 years, you walk around the Earth. You circumnavigate the Earth, which is kind of cool. Now, we only ever see one side of the moon when we're on the Earth because the moon is tidally locked with us. It's tidally locked with us. And it shows only its near side. only its near side. We do not see the far side of the moon. It's the main driver of the tides on the Earth. Why are there tides on the Earth? And like I say, the strength of the gravitational field on the moon is 1/6 of what it is on Earth. The surface of the moon is full of impact craters and what are called Maria, like dark seas. We used to think that they were seas or oceans, but we know that they're not now. So how much of the moon is visible from the Earth? How much of the moon is visible from the Earth? So you would think, wait a minute, it's tidally locked with the Earth, and I only get to see one side of it, so is the answer 50%? No, it's not. The answer is 59%. Why is it 59%? Because the moon wobbles like that when you actually look at it, and that's called libration. Libration. And it's the brightest object in the night sky, although that goes without saying. It obviously is. And because of its size, that's what enables total solar eclipses, as I said. Now, people are allowed to be skeptical and not believe this, but I'm just going to say what's commonly out there. And people say that the Apollo 11 mission landed humans on the moon in 1969 with 5 more crews after that landing until 1972. And they've been saying now since forever that future missions to the moon are planned. Well, we'll see in 100 years if they actually do it. Okay, so now let's talk about the number one. Right here. Earth. Let's talk about the Earth. The Earth is the third planet from the Sun, and it's the only known host of life. And when did it form? Supposedly around 4.54 billion years ago. And it formed via accretion of dust in the early solar system. The shape of the Earth is not completely round. It's actually ellipsoidal, kind of like an abacus bead, but squashed, it's flatter at the poles. So, how wide is the Earth? The answer is 12,742 kilometers at the equator. Right? Okay, and how about its structure? Well, it has an iron core, which is surrounded by the mantle, which is then surrounded by the rocky crust. The atmosphere of Earth, which is what we are breathing right now, is not pure oxygen. It's not pure oxygen. Actually, it's roughly 4 parts nitrogen and 1 part oxygen. But the more precise figures would be 78% nitrogen and 21% oxygen. And then there are trace amounts of carbon dioxide and argon and other trace gases. The surface of the Earth is obviously covered mostly in water, as you can see from satellite photographs. But how much exactly? Well, around 71%. Around 71%. And a lot of it, most of it is in the oceans, of course, and at the poles, in the ice caps. But then a very important small amount of it is in rivers. That's very important to us, right? In fact, the first settlements and towns were mostly around rivers. So I really wish that people would actually care about rivers and look after them because of this. But anyway, that's neither here nor there. So, what is it that causes earthquakes and volcanoes? Well, the answer would be seismic activity. That's what causes earthquakes and volcanoes. And that's because the surface of the Earth is comprised of tectonic plates, which are not totally fixed. They are moving somewhat. And sometimes they glide past each other, sometimes they push into each other, and it can cause earthquakes and volcanoes because of this. Okay, so did you know that we have a magnetosphere and that planet Mars doesn't? And this is what prevents us from like being cooked to death by the sun. And it's generated by the liquid outer core. Okay, moving around, the liquid outer core moving around. So if we were to actually live on planet Mars, we would have to live underground to be protected. Okay, let's now think about what is it that causes the seasons? What causes the seasons? Well, if you're younger, you might think it's because the Earth is sometimes closer to the sun or something like that. But that's obviously nonsense, because when it's summer in the northern hemisphere, it's winter in the southern hemisphere, and vice versa. So it's caused by the fact that the Earth is tilted on its axis by about 23.5 degrees. And it rotates on its axis. This axial rotation causes the day and night cycle. So the axial tilt causes the seasonal cycle, and the axial rotation causes the day and night cycle. An ocean. Let's now talk about an ocean. I love the ocean very much. An ocean is a large water body of the Earth's hydrosphere. Around 71% of the surface of the Earth is covered in oceans, as we know. And really, there's just one ocean called the World Ocean, but we artificially divide it up and into the Pacific, Atlantic, Indian, Southern, and Arctic oceans. The world ocean has around 97% of the water of the Earth and more than 240,000 species, all the way from phytoplankton to blue whales. The photic zone is up to 200 meters deep, and it's what allows photosynthesis to occur on the ocean. And it gives around half of all the oxygen that we breathe in and out every day. It influences climate, weather, and the carbon cycle because it has a role as a heat reservoir. There are currents like the Gulf Stream, which redistribute heat and pollutants. The surface temperature of the ocean varies quite a bit, from more than 30 degrees Celsius in the tropics to -2 degrees Celsius at the poles. CO2 levels are rising in the atmosphere, as we know, as we're constantly told. And this causes ocean acidification. It causes ocean acidification because carbon dioxide dissolves in the ocean. And more than 3 billion people actually rely on the ocean for food and jobs. This is called the blue economy. And there are major concerns about pollution, overfishing, and climate change, of course. Now let's talk about rivers. I mentioned rivers earlier, how they were extremely important for the first settlements that humans made. We first settled by rivers for potable water. A river is a large natural water stream, often multi-channeled, but sometimes ephemeral, appearing and then disappearing. How do they actually come about? Well, they're fed by precipitation, rain, snow, sleet, and runoff, and springs, and meltwater. They only hold a very, very tiny percentage of the Earth's fresh water. How much exactly? Well, you might think maybe around 1%. No. Okay. 0.1%? Nope, not even that. 1/4 of 1/10 of a percent of the fresh water. But despite having so little, they cycle 7% of the global precipitation between the lands and the oceans. That's how important they are. They erode and transport sediment. The Ganges, Brahmaputra, and Huanghe, hope I'm saying that right, or close to right, are major contributors. They shape landscapes, they form waterfalls, valleys, and deltas. And how much surface of the Earth do they cover? Well, about 0.1%. So, we know that they support ecosystems, as we were just reading The Wind in the Willows. And they're central to human civilization, as I've said a few times. The longest river in the world is the Nile of northeast Africa. It's around 6,650 kilometers long. Now let's speak a little bit about forests, because I'm kind of interested in those. They are defined as large, densely wooded areas. And how much of the land of Earth is actually covered in forests? Maybe about 1/3? Well, that's actually remarkably close. It's around 31%. They, let's see here. The different types come about by different latitudes and different climates. Like you have boreal forests in the subarctic, tropical at the equator, and temperate in mid latitudes.
Around 75% of Earth's primary production is in forests, and 80% of plant biomass is in the forests. The photic zone supports photosynthesis, as we know, and that's vital for oxygen production. And let's see, the Amazon is the largest forest. Okay, I think a lot of people know that. Okay, let's see. Okay, I don't have much more to say about those. Let's now speak just a little bit about deserts as our last topic. A desert is a barren area with very sparse precipitation. That's the definition. They're defined as, well, that's part of the definition. They're defined as having less than 250 millimeters of rain each year. And they do take up a third of the land, about 33% of the land. This includes cold deserts, like in the polar regions, formed by weathering by temperature shifts, which leads to phenomena like sandstorms. And some of the most famous features are dunes, oases, rock outcrops, and yeah, we know famously that flora and fauna have survival adaptations, like cacti, how they store moisture, and camel humps store fat. Many of the creatures in the desert are nocturnal. I mentioned hot and cold deserts. The largest hot desert is Sahara, and the largest cold desert is the Antarctica. The Atacama, which is the driest desert, has something known as super blooms. Desertification, which is often caused by humans, is a real threat. Climate change endangers their ecosystems, but solar projects are possible. Okay, so that was just our first slice of general knowledge. Let's now see. Um,